y'all, perhaps you noticed that our pictures changed a little bit because we're no longer up a creek without a paddle. Now we've got the tools of mathematics to build ourselves a sail and sail off into the sunset. Let's apply those tools. Hopefully you've already sweat through this. Your paper might be dripping wet because you've worked so hard, in which case I'm proud of you. If you haven't done that, then you better stop this video right now. Here we go. Cosecant plus cotangent of x is equal to 1. Now I wanted to do this one because there's two different ways of doing it. Both are correct. It's okay whichever way you do it. First, I'm going to do it the way that I think you did it. Let's find out. I think that you used the exact same method before. So you notice that we have two different trig expressions. So you decided to try using an identity to make them all the same. So I think that you chose to use the reciprocal and ratio identities, okay? Tried to make everything sine and cosine. So here is method 1. Cosecant's the same thing as 1 over sine of x. Cotangent's the same thing as cosine of x over sine of x. Now we've already got the same denominator, so we can go ahead and add our numerators together. So we've got 1 plus cosine of x divided by sine of x is equal to 1, okay? Now we can pass sine of x to the other side, so I think that you probably did that. However, we need to remember that since sine of x was in the denominator at this point, that means that sine of x cannot be equal to 0, right? Because we cannot have 0 in the denominator. So I'm just going to make a little note that sine of x cannot be equal to 0 because we cannot divide by 0. So we got to keep that out, okay? Oh, this should be sine of x, shouldn't it? Sine of x. There, perfect. Now, it looks exactly the same as our previous problem. 1 plus cosine of x is equal to sine of x. So I'm going to do the exact same thing. Shall we just fast forward and end up with 2 cosine of x times cosine of x plus 1 is equal to 0? Let's just fast forward. So we squared both sides. You're going to end up, what did I say, 2 cosine of x times cosine of x plus 1 is equal to 0. Ooh, fast forward. If you need, go back and rewatch that portion of the video. Okay, so I can set them both equal to 0, so cosine of x is equal to 0, right? We would divide by 2, and cosine of x is equal to -1. So we've got x is equal to 0 at pi over 2 and 3 pi over 2, and x is equal to -1 at x is equal to pi. When x is pi, we've got cosine is -1. However, let's just remember real quick that sine cannot be equal to 0. But when x is pi, sine would be equal to 0. So we can go ahead and say that that is not a solution, okay? If you forgot that, that's okay, because you're going to check your answers, right? Remember that if you ended up squaring both sides, you've got to check for extraneous solutions first. So let's suppose that you didn't remember that, and we're going to check them all. Now, because cosecant and cotangent, I don't know off the top of my head, I don't know using my fingers, I don't really know using the unit circle, I'm dependent on sine and cosine to figure them out. I'm going to plug them into this second equation where I went ahead and transformed them, okay? So I'm going to check using the equation 1 sine of x plus cosine x over sine of x is equal to 1, okay? So first, let's do pi over 2. So I'll have 1 over sine of pi over 2 plus cosine of pi over 2 over sine of pi over 2. I want to see if that's equal to 1. Is it equal to 1? So sine of pi over 2 is 1. So we're going to have 1 over 1 plus cosine of pi over 2 is 0. Sine of pi over 2, it doesn't really matter, but it's 1 still. Is equal to 1. 1 divided by 1 is 1. 0 divided by 1 is 0. 1 plus 0 is 1. So x equals pi over 2 is a valid solution. It works. Okay? Let's try 3 pi over 2. So we're going to have 1 over sine of 3 pi over 2 plus cosine of 3 pi over 2 over sine of 3 pi over 2. We want to know, does that equal 1? Let's do a little spacer here. Sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is still negative 1. 1 divided by negative 1 is negative 1. 0 divided by negative 1 is 0. Negative 1 plus 0 is negative 1, not positive 1. So it doesn't work. You can either cross it out or just ignore it. Just box in your final answers. All right, last one. X is equal to pi. Should we scoot it up? Let's see what happens. So again, plugging into this equation, I've got 1 over sine of pi plus cosine pi over sine of pi is equal to 1. Sine of pi is 0, so we'll have 1 over 0, plus cosine of pi is negative 1 divided by 0. We cannot divide by 0. That is a big no-no, so this is not a solution. So we had 2 extraneous solutions using this method. There's only one actual solution, x equals pi over 2. Okay? You don't have to box it in twice. I just did it for emphasis. All right, let's look at method 2 that I think you did. I think that some of you were like, well, cosecant and cotangent, I remember that from that last test a while back, our first ongoing one of those identities. But I remember that they need to be squared. But that identity, it was cotangent squared of x plus 1 is equal to cosecant x squared, cosecant squared of x, right? We remember this identity. Same thing as sine squared plus cosine squared is equal to 1, just we have divided everything by sine squared to get this new identity, okay? So I'm going to use this identity. So I'm not going to change it to this and combine like terms. I'm going to use this, and I'm going to square both sides to make it into having squared terms, right? Because right now it's cosecant to the first, cotangent to the first, and I need it to be squared to be able to use this identity. So I need to square both sides. However, remember that if we are going to square both sides, we first need to separate the trig expressions to be on opposite sides. Right now they're on the same side of the equation, so I'm going to pass one to the other side. It does not matter which one I pass. Doesn't matter. So what I'm going to do is pass cotangent. That cool with y'all? So I'm going to do cosecant of x is equal to 1 minus cotangent of x. Okay? So I'm hoping to be able to use this. And then I'm going to square both sides. Squared. Oh geez, I put my square in the wrong spot. Squared. Hope that doesn't mess y'all up. So I'm going to have cosecant squared of x over on here. And then over here, I've got to distribute. So I'll write it out. 1 minus cotangent of x times 1 minus cotangent of x. Distribute that. When you do, I'm going to just kind of skip it. Well, I'll do it all. 1 minus cotangent of x minus cotangent of x plus cotangent squared of x is equal to cosecant squared of x. Combine your like terms. So we're going to have 1 minus 2 cotangent of x plus cotangent squared of x is equal to cosecant squared of x. All right, we've combined our like terms. We've done what we needed to do. Now we're going to apply the identity. Cosecant squared is the same thing as cotangent squared of x plus 1. So I'm going to replace this cosecant squared with cotangent squared of x plus 1. All right, everything else stays the same. Equals 1 minus 2 cotangent of x plus cotangent squared of x. Okay? Now, what I have is the same trig expression, but different exponents. So now I can follow the rules for if I can factor. I need to get it equal to 0, so I'm going to pass everything to be on the same side. Okay, so I'm going to do minus cotangent squared, but here it's positive. So cotangent squared minus cotangent squared will be 0. They're going to cancel out. Okay, let's do another color. Cancels. 1 minus 1 will cancel. So I'll be left with negative 2 cotangent of x. 0 is equal to negative 2 cotangent of x. If I divide by negative 2, 0 divided by negative 2 is still 0, so that negative 2 can get gone. So I've got cotangent of x is equal to 0. Now, like we said before, cotangent we don't have on our fingers. We're dependent on sine and cosine. So now I'm going to transform cotangent to be in terms of sine and cosine. So cotangent is cosine of x divided by sine of x. That's got to be equal to 0. Okay. Now this can only be equal to 0 if my numerator is equal to 0. It doesn't matter what my denominator is, my numerator has got to be equal to 0. So I need for cosine of x to be 0. Now this looks real familiar. Cosine of x has got to be 0. That only happens at pi over 2 and 3 pi over 2. Now lucky for us, we already went through the strenuous work of checking it. So I'm just going to refer back to over here. So when we checked pi over 2, it worked. When we checked 3 pi over 2, it did not work. So pi over 2 is our only solution. Okay, so same answers, different methods. It doesn't matter which one you do, you're going to get the same answer. Choose the one that works best for you. All right, call me over if you got any questions, per usual.